murderer out there looking for you. I'm going to try and protect your privacy as best I can.
Alrighty.
Okay, we're live. Okay, yeah. Simple arithmetic sequence. We can sometimes say, we tend to say, yeah, the limit of this sequence as n goes to infinity is infinity. Really, infinity is not a number, it's an idea, so technically that limit doesn't exist. Okay, and that one's pretty simple, so we'll just pretend it was never here. Goodbye.
So the limit for that one's infinity?
Yeah, the limit for that one is infinity. Yeah, we might express it that way.
But it doesn't exist or something you wrote?
Yeah, technically the limit doesn't exist, right?
Because it's not like an exact.
It's not a number, really. And yeah, infinity is not a number.
All right.
Okay. Here's our second example. Okay, so this is a rational example. It's a rational function, and 3 over n plus 1 over n plus 1. So term 1 is 2, term 2 is 2.3, term 3 is 2.5. And if I keep on going, I want to know, does this converge to a specific value? Okay. So as n gets really, really large, what happens to the value of this? Maddie, you already know.
Sorry, it gets closer and closer to 1.
Are you able to see it?
Yeah, it's just really, really blurry.
Oh, is it?
Yeah.
It's
Okay.
not too bad for me.
Okay. Sorry about that, Maddie.
That's okay. I can read it. It's
just like
and the audio
pixelated?
kind of goes sometimes too. So sometimes I only get half the sentence.
Okay. If we can work on the quality issues, you know, on both ends, whether that means like getting you a LAN cord or something, just, I know like for you it's not limiting, but for some people it's important to see it. Anyway, this is 3n plus 1 over n plus 1.
So it would be approaching 3.
Yeah, so as n goes to infinity, this is going to head towards 3. Yep. Okay. Now there's a kind of a formal technique that we use that just sort of helps you understand why that heads towards 3. Okay, so limit as n goes to infinity. We multiply the top and bottom by 1 over n. Okay.
So is that like the same as dividing by the highest
Highest power,
yeah.
highest exponent. Yeah.
Yeah. Okay.
Yep. Similarly illustrative. Very good. Okay. Okay, 3 over n divided by n is just 3. 1 times 1 over n is 1 over n. Okay. And 1 over n times n is 1. And this is going to be plus 1 over n. Okay. Now, I can apply my limits in this case. So the limit as n goes to infinity of 3 is just 3. The limit as n goes to infinity of 1 over n, so 1 divided by some really big, huge number is just 0. Okay. And similarly, as n goes to infinity, 1 just becomes 1, and this becomes 0. Okay, so I've applied my limit. Now I can see that this is just basically 3 over 1. So it's kind of an algebraic demonstration. I can see that that limit goes to 3. All right. Johnny, did that make sense?
Yeah, but why did you multiply it by 1 over n?
I multiplied by 1 over n basically so that in this lead term, I'm able to cancel out my n and see what the values become. Okay. So as Maddie said, you divide it by the highest power of the lead term, and we'll look at an example where we do that.
So the limit as n goes towards infinity is 3.
Yeah, so this expression, 1 over n, if n is infinity, is just basically 0, right? So these both just basically head towards 0, and these terms dominate. So it just turns into 3 over 1, basically.
Is that the limit, though, 3?
Yep, the limit is 3.
Okay.
Okay, converges to 3. So as long as the power of the top is equal to the power of the bottom, those are pretty easy. Okay, so here's the last example that we look at when we're dealing with these sort of discrete functions. And in this case, this is the example where the function does not converge to a limit. And this has to do with the fact that it's jumping around, okay? So the value is negative here, and it's positive here, and it's negative there. And it's because the inside of this, what is a power expression, or an exponential relationship if we looked at the whole thing, the inside is negative.
So to figure that out, you're just plugging in like 1, 2, and 3, and then you can see.
Yeah, so I can already see I've got a problem, right? Because it's going negative, positive, negative. So the whole idea that this is going to converge to a limit is, oh, hi Morgan. Morgan's, she's mystery, but she's here. Okay. All right. So limit as n goes to infinity of 3n plus 1 over 1 minus 3n to the exponent n. I'm going to pull the same trick again. Okay, limit as n goes to infinity, 1 over n times 3n plus 1, 1 over n times 1 minus 3n. Maybe I should make these square brackets. Oh, look at those big, handsome square brackets. At least I hope you can see them, Maddie. Made the best square brackets ever there. Okay, can I go? I'll go down here. I think I can. It's 3n over n is just a 3, plus 1 over n as n goes to infinity. Oh, I forgot to put a big n up there, everybody. Okay, and this becomes 1 over n minus 3. Okay. So this part just basically becomes, so sorry, I'm going to apply the limit to the inside without really formally symbolizing it, because I think it might keep it a little bit cleaner. As n goes to infinity, this becomes 3 plus 0 on top. And on the bottom, it becomes 0 minus 3 to the n. Okay, so I haven't shown it, but I've applied the limit to the inside without applying the limit to the outside function. Okay? 3 plus 0 over, oh, this is a little extra step I'll put in. This just basically becomes 3 minus 3 over negative 3 to the n.
So this could be either positive or negative 1?
Yeah. So every term is going to switch from being positive to being negative. So consecutive terms are actually going to go positive 1, negative 1, positive 1, negative 1. So this is equal to 1. And if n is negative, this thing is equal to negative 1. Okay? So if I looked at this as it heads for infinity, it does not converge. Okay? So it just basically does this, back and forth and back and forth. It's 2 different values as n gets really large.
Stop that.
Is that cat again?
Yeah, he's scratching the scratch post.
Well, that is what he's supposed to do.
Yeah, but he's interrupting the learning.
Yeah. It's an anti-learning cat.
Yeah.
They were originally bred by the Chinese as a way of slowing down capitalism by by making everybody more poorly educated. Okay. Sorry, that was Maddie. Maybe you didn't want to know us that well, but okay. We're just going to go to rational functions now, and we've got three conditions. Okay. We've got the condition where the degree of the top is greater than the degree of the bottom. Okay, so we could be asking for the limit as x goes to infinity of x to the fifth plus x minus, I don't know. I like to put 10,000 into these. I'll put a 5 here. Will the internet be angry with me if I put a 5 there? I know, like, you guys have formatted your notes. I'll put a 5 right. No, I'll put a 6 here. Oh, I'm really going to switch it up.
Morgan said it won't let me unmute myself. Is this just part of the lesson, or is this homework questions?
Oh, this is just part of the lessons. Okay, and then we can take up homework questions after the lesson. We did that. We did that here as well. Okay, so there we go. Degree of the top is greater than the degree of the bottom, and Maddie she's got a plan for this one already. What are we going to do?
Divide by the highest degree.
Yeah, so we're going to divide the top and bottom by x to the fifth. Shouldn't have made such a big polynomial. So much work. By the way, I expect you to be able to explain why this works, but I'm not going to ask you like to do a bunch of multiplying by 1 over x to the fifth on a test. So 6 over x to the fifth divided by x to the fifth is just 6, plus x divided by x to the fifth is 1 over x to the fourth, and negative 10,000 divided by x to the fifth. And this is my top. I don't actually need to put a bracket on that, so I won't. Okay, here we go. This becomes 5 over x squared plus 1 over x to the fourth plus 500 over x to the fifth. Okay. The top, basically when the limit goes in, 1 divided by a big number to the fourth and 10,000 divided by a big number to the fifth, is just basically 0. The bottom, on the other hand, basically heads towards 0. In other words, gets really, really, really small. And I shouldn't be popping a 0 in for x. I shouldn't be, well, I guess I can put a 0 in here. Basically, the bottom gets really, really small. So we just say something like 6 divided by something really, really small is basically infinity, okay? So as x goes to infinity, f of x also goes to infinity, okay? I think that's a summary. I don't think you have to really go over that on a test.
Is that undefined, or?
I would say, what is the limit of this? And you would just say, as x goes to infinity, this goes to infinity, and I would be happy with that. You'd have to say the degree of the top is greater than the degree of the bottom, but I'd be happy with that answer. Okay, so you don't have to go through this part of the song and dance. Does that make sense?
How do you know f of x is going towards infinity?
It will ask you for the limit as x goes to infinity. It'll be very literal. Make sense?
But isn't 0 plus 0 plus 0 0, and isn't that undefined, or what does that mean?
Yeah, so I was saying there's a bit of monkey shine in here when I write in zeros, because as x goes to infinity, these technically don't become 0. They just become practically 0. Okay?
Okay.
Okay, so yeah, you're technically right. It's undefined, but really what you're trying to illustrate by doing this is just saying this is 6 divided by something super tiny, and it's headed for infinity. But you're right. Like,
Oh, okay.
yeah, you're right. Like, I technically can't do that. Just, I hope nobody's watching on the internet, so
small.
I'll get kicked out of whatever the don't divide by 0 math club.
6 divided by something like a very small fraction, like 1 over, like, I don't know, let's just say 100. When you divide those, you're gonna flip that, and it'd be like 6 times 100, right? So it'd be
Exactly.
Like,
Yeah. Yeah, that's the idea. You got it, Pontiac. By the way, that's a car rather than a Native American reference when I say Pontiac, but Pontiac was named after Pontiac. Okay. Do they still make Pontiacs?
probably.
Yeah, it's a General Motors product. Yeah. Okay. All right. All right, let's take this to infinity. Everybody hang on. This one's going to be exciting.
Will these kind of questions be on the test?
Yes, potentially. Do they seem intimidating?
No.
Okay, that's good. Because yeah, these are actually pretty easy. Okay, there we go. I want to find out if this converges. And Maddie's already looking at that and saying, I did this in advanced functions.
Oh.
This converges to a value. What is it?
1.
No, you're wrong. Yay, I get to teach you something finally.
Oh, no, it won't be. It'll be 5 over 3. Sorry.
Yeah, so it converges to 5/3.
Yeah.
Okay. All right. It's not me teaching you something. It's me writing big enough so you can actually see it. Okay. All right. Everybody, I'm going to go through the same song and dance. This is an advanced functions song and dance. Multiply top and bottom by 1 over x to the 5th, which is just basically the largest power of x in the top and bottom. And I made it shorter now because it's extra work to write it out. Plus, I think maybe this whiteboard marker might cause cancer. I'm not sure. There we go. It's made in a place where they want to make a lot of profit on whiteboard markers. So there we go. Okay. 5x to the 5th divided by x to the 5th is just 5. 10x divided by x to the 5th is 10 over x to the 4th. Okay. And 1 over x to the 5th times 3x to the 5th is just 3. And x squared over x to the 5th is 1 over x cubed minus 1 over x to the 5th. Okay, good. I think I can safely put in the zeros without being turned over to the don't divide by 0 police. I hope, anyways.
Minus 1 x to the 5th or 1/5?
Oh. Look at that.
Okay.
I was just testing, Johnny. Very good. I'm going to go over here and put a check mark beside your name.
Nice.
Eric just saw me put a big stroke through your name. I don't know what that means. Okay. I'm just kidding. Okay. As x goes to infinity, 5 stays cool. 5 was born in the 70s. Okay. 10 over x to the 4th, though, I'm pretty happy to say that's pretty much 0 as x goes to infinity. Born in the 90s. Okay. So here we go. 3 as x goes to infinity also stays cool, even though it was the parent of 5, which was born in the 70s. Hard to believe it could stay cool through all that intergenerational turmoil. Okay. Anyways, good. I put in zeros. Johnny, you won't be upset now that I put in zeros and like now I'm just dividing by 3. Okay, so this is just basically 5/3. This thing heads for 5/3. Okay. And I'm even going to draw it. What's the word we say when a function heads towards that value? Is that your cat, Johnny? That
I don't know what he's saying.
Chinese breed of cat? Okay, so
I don't know the word for
Himalayan.
whatever you're asking, no.
Yeah, it's an asymptote. Okay. Yeah, so this just basically heads, as x goes to infinity, this heads to an asymptote of 5/3. And I think it's going to approach it from above, but I'm just guessing. There we go. Okay, so that's what it looks like. It's a continuous function, not a discrete function like the ones we had at the start. So if the degree of the top is equal to the degree of the bottom, there's a really good chance that the limit will converge as x goes to infinity. All right, good enough? Thumbs up? All right, I've started to write bigger, Maddie, so that you can actually see.
Anytime the video clears up, the audio goes out.
Oh, really?
Yeah, it's funny.
Oh, okay.
I'm
All
good.
right.
I got you for the most part.
Okay, last one. This is where the degree of the top is less than the degree of the bottom. So I'm just going to make...
So what's that 5/3 mean? Like that's the limit?
Yes. Yeah, so we say the limit as x goes to infinity, in other words, gets really big, is 5/3, meaning that the function heads for that value as x goes to infinity.
All right.
Okay. All right. There's my function f at x. We're going to send x to infinity. Okay, now it wouldn't matter if I put an x squared here, or if I put an x to the 5th, or if I put an x to the 7th, or if I had an x to the 7th on the top, I could have an x squared on the, sorry, if I put an x to the 7th on the bottom, I could have like x to the 5th up here. The important thing to notice is that the degree of the bottom is greater than the degree of the top. Okay, I'll just flip this back to the original. Okay, so that's the simplest version. X is headed for positive infinity out here. And what's the graph going to look like?
Maybe a hyperbole.
Yeah, it's just going to be asymptotic, okay? Basically, when x is really large, this is 1 divided by a really big number, so basically this thing is headed for 0.
Would the asymptote be 1?
No, the actual asymptote is y equals 0.
Would be
Right?
a vertical asymptote at 1, though.
Oh, I see what you're saying. Yes, Maddie's right. It has a vertical asymptote at positive 1. Okay.
And the limit is the horizontal asymptote.
And the limit in this case, yes, the limit as x approaches infinity is this horizontal asymptote. Yeah. Thanks, Maddie. Not bad for somebody who can't see or can't hear or like
No, it's fine.
alternating. Okay, good. Now, provided I've drawn this correctly, what is the limit of this function as x approaches 1 from above?
Wait,
There are
is there a
two.
second
I'll
half
accept
of
2 possible answers. What's
Is
that,
there-
Maddie?
Is there a second half of the function on the left side of the asymptote there?
Oh, is there another one here?
Yeah.
And I'm going to approach 1 from above, though, just for
Okay,
now.
just you know.
Yeah.
What's What's the difference? Like from
Can you see this 1 here, Johnny?
Yeah.
Okay, and there's my vertical asymptote. So if I'm approaching 1 from above, or in other words, I'm approaching 1 from the right, I'm coming at it from this direction.
Mm-hmm.
Right? Okay, so I'm approaching 1 from the right, and 2 answers for this question. What's the limit as I approach 1 from the right? You could say, well, the function heads for infinity, so I would accept that as an answer. Or you could say does not exist. I would accept both. But I'd really kind of like to see you say it goes to infinity.
Like in the homework the other day, there was like, say it was like x approaches -2 from the left or right. What's the difference? How do you know without graphing it? Like what's it? Are they both different?
They can be different, and so most often you're answering like a graphing style question when it does that. The exception is where you've got a jump discontinuity at a particular point. Okay, and there are a few approaches. You can put in, like, if it's approaching from the right or from above, an x value of 2, for example, you could literally just substitute values of x that are just a little more than 2 into the function. 2.1, 2.01, 2.001, and see what happens.
Same answer for all of those if it does exist?
Yeah, you'd be able to calculate those directly in the function. Like, you'd be able to substitute those in.
Are we gonna have a question like that on the test with like?
I already told Maddie no, but the example, so the classic example is a function that involves an absolute value function. Okay, but I kind of committed to not putting that on the test in period 1, so good question. No, you won't have to do it on the test.
Okay.
But I might ask you, I'm going to put graphs on, and I'm going to ask you questions about those graphs.
Okay. Like, does the limit exist and stuff like that?
Yeah, or what is the limit as x approaches 3 from above? What's the limit as x approaches 3 from below? And you'll just look at the graph.
All right.
So
Okay.
So,
sorry.
Oh, what's that, Maddie?
How do we submit our tests? So like if you email me a copy of the questions and then I write them out, like write out my answers.
Yeah.
Or is it then I like send you pictures of my answers back through email?
Yeah.
Okay. I wasn't sure
Yeah.
how we were submitting that.
If you're connected to OneNote, you can put them in OneNote and just tell me. But yeah, you can email them to me, and yeah.
Okay.
And usually when you email them, I put them back in your OneNote. Have you been able to find your OneNote?
No, I don't think I was invited to the page.
Oh, yeah. Okay. Well, it is an exclusive club, so don't.
I figured.
Lots of people get rejected.
Sit there and make fun of me the whole time. Yeah,
okay. I'll check again I'll invite you again,
right.
or maybe for the first time. I'm not sure which.
Are you using my board email or the email that I gave you for the iSTEM?
I always use the email that you check.
Okay, perfect.
Now, when you go into OneNote, you do have to log in with your board username and password to make it work. Yeah. Yeah, no, it's like a kiss of death when somebody says, yeah, here's my email, and it's a board email, and like the turnaround time on those emails is literally, it's 5 days. I've got this problem, I can't do anything.
Can you see this, Mr. Rogers? If I put this up like this?
See if I can make it big.
It'll be backwards though, wouldn't it?
Is it backwards? Oh, yeah, it might be backwards for me.
I don't think it really matters. So if there's like an open dot there,
yeah,
and then there's a closed dot above it, but it's on like the same x value.
Yeah.
Like, what's the limit?
Okay, so the answer to that is that the limit does not exist.
Because it like there's 2 different ones.
Yeah, so the limit from above is 4. The limit from below is 1.
Okay.
Okay, so you can calculate the limit from the left. You can calculate the limit from the right, or sorry, I should say find And since they're not equal, the limit itself does not exist.
All right.
Yep.
That was my question.
Okay. Good. So we'll take up a little bit of homework now. Yeah, we'll just do a little bit of homework if somebody's got. I know Morgan's got some homework questions. So Morgan, if you're listening, you can type in like do 6A, and I'll do 6A. Preferably 6A because we already did it. So I think I even got it right.
Is this from the homework from the
Yesterday.
limit? The like 1 to 4? AB?
No, this was for functions containing radicals.
Yeah, so like 1 to 4, 5 ABF, 6 ABF, 7 A, 8 A.
Exactly, yeah.
Yeah, my question was like the left to right thing.
Oh, okay. There was a question that everybody found challenging yesterday, which was number 2, actually.
Yeah, that was the one I.
Oh, right. And I said we'd look at it. So Johnny, if you've got Morgan, you can just text her and say we're doing homework now. And if she wants to tell me what homework she wants to see done.
Tell her. And then like for 3, it's like find the limit as x approaches 0 from the right, and it's x squared over the square root of 3x. Do you just sub in 0 then?
I'll take a look at it, but because it contains a radical, it might behave a little bit strangely, okay? So this is number 2 from the homework yesterday. This is the limit as x approaches 2. And if you actually plotted this in Desmos, or you happen to be able to recognize it, it's a circle, okay? So Johnny, as x approaches -2 from above, what's the value of the limit? Just looking at it graphically.
From above?
Yeah.
0.
It's 0, yeah. Okay. Now, sorry, and that's -2 from above. What's the limit as x approaches -2 from below? Ooh,
0.
Okay. So I'm approaching -2 from this direction.
Yep.
Doesn't exist. The function doesn't exist here.
How do you know that?
I'll show you in a second, but you can see this is a circle, and it exists at the point -2 and goes around to there, and then it quits existing again. Okay.
Wouldn't it be the same for the right though?
So do you mean we're approaching -2 from above?
I thought you meant, well, it's not the same thing.
Okay, so I approach -2 from above, and the function heads to 0, right? Comes down this way and heads to 0. If I approach -2 from below, though, the function doesn't have a value, right? Like there is no function value below -2, so it doesn't exist.
Okay.
All right, and I'll do the algebra for that in just a second. Okay, since the limit from below doesn't exist and the limit from above is 0, the limit as x approaches 2 does not exist. Algebraically, the reason it doesn't exist when x is approaching -2 from the right is because x squared minus 4 absolutely has to be greater than 0 greater than or equal to 0. Can you tell me why?
No.
Okay. I can't take the square root of a negative number. So anything that would make x squared minus 4 a negative number isn't a permitted value. Okay?
Yep.
That part makes sense. Okay, all right. Try and solve this inequality. We know that x squared has to be greater than or equal to 4.
Take the square root of 0.
You can take the square root of 0, yeah.
Is it just 0?
It's 0, yeah.
Okay.
All right. Okay, x squared has to be, oh, does that work? Yeah, that's right. So x squared has to be greater than 4. No, this doesn't work. Do I have this backwards? I don't. X squared minus 4, yeah, that's right. That's right. Yeah.
Do you have to write that stuff down, or can you just sub in 2?
Oh, this is 2a. Yeah. Oh, just a minute. No, this is correct. Okay. Anyways, this only exists when I have x values. So this should be x squared has to be.
Yeah, no, that's right. 'Cause that means the values have to be in between positive and negative 2.
Yeah, it's got to be
There we
between
go.
negative 2. Oops. Get that backwards. Yeah, it's got to be between positive and negative 2. Okay. All right. Anyways, so this has limitations because of domain restrictions. So that was one of the reasons that a limit doesn't exist. All right. Was Morgan able to, were you able to get in contact with Morgan?
I messaged her, but she didn't open it.
Okay.
Let's do number 3.
Do number 3? Okay. Give me a second to bring it up here.
She said, yes, I need 6A. She thought she messaged it on the screen, but it maybe didn't pop up.
Okay. We maybe didn't see it. Okay. Johnny, I'll do 6A.
Okay.
And then we'll go back and do 3. So this is square root of 9 minus x minus square root of 9 plus x. Over x. And the limit here as x approaches 0. Okay. So the first thing it actually says is show that this is indeterminate. So that means when I substitute 0 in for x, basically show that this turns into 0 over 0. So if I put a 0 in here, square root of 9 is 3, and a 0 here, square root of 9 is 3. 3 minus 3, top is 0, x is headed to 0, so the bottom is 0, so this thing is indeterminate. Okay? Verified, it's indeterminate. Okay, limit as x goes to 0. 9 minus x minus 9 plus x over x. Okay. Magic trick we learned yesterday that we do every single time. Multiply top and bottom by the conjugate. Okay? So in other words, just change the sign in there. There we go. So we can fix this, people. We can make it better than it was before. We can rebuild him. You actually recognize that $6 Million Man reference?
Yeah, I used to watch that. Watch it with my dad.
Oh, okay. All right. Yeah, had a bionic eye. Okay. So via the magic of conjugates, the top becomes 9 minus x minus 9 plus x.
9
Okay.
minus x, right? Oh, sorry, I didn't see the brackets. I see them now.
Okay. All right. Ha-ha!
The audio came in before the video caught up, and I was like, wait.
Okay. And I am just going to leave the bottom alone because some magic happens, and I don't want to spoil it by fixing the bottom. Okay. Now I'm going to go and simplify stuff. That part's gone. Nine minus 9 is nothing. Negative x minus x is negative 2x on top, x on the bottom. Okay. We tried it this morning. We put in a 0 at this point. Oh, my writing is terrible. Eric is squinting. No technology limitations. We put in a 0 for x, and it was still 0 over 0. What can we do? I can hear you thinking, Maddie, just cancel out the x's. Okay. It becomes negative 2 over square root of 9 minus x plus square root of 9 plus x. Oh, toxic. Just keep your hands down if you think you're going to forget to write in the limit part right here when you're solving these. I know my hands are down. Okay. Now I can put in a 0 for x because look, this is the square root of 9 plus the square root of 9. So the bottom is 6, the top is negative 2. Okay, being ever cognizant of that. And so this is just negative 1/3. Okay. So the big secret there the whole time was just multiply top and bottom by the conjugate. Same thing's going to happen if you're doing like a difference quotient problem. Multiply the top and bottom by the conjugate, simplify, cancel. Yep. Just from here, Johnny, you do look a little bit like you could be a serial killer.
Yeah. Yeah. I forget how to do the conjugate. I did it yesterday.
Okay. Okay, so I know that
just
there.
But when you multiply them, how do you get? Because square root of 9 minus x times, I don't know.
Sorry,
Time.
where did you get lost?
When you multiply times the conjugate, I just forget like what that is. Because I know the square root of 9 minus x times the square root of 9 minus x is just 9 minus x, right?
Yeah. Okay.
And then you get that second part up top.
Okay. So what is the conjugate of this expression?
It's square root of 9 minus x plus the square root of 9 plus x.
Yeah.
I just forget how to get that second half of the.
You mean after this part?
Yeah.
Okay.
I know it's going to be 9 minus x and then the second part of that.
Okay. So basically, you're just doing the distributive property on this. Okay. So I'm multiplying this by this, right?
Mm-hmm.
Okay. So that just becomes 9 minus x.
Yep.
Now you have to stay cognizant because it's easy to fall into this comfortable honey trap of thinking that whenever you're doing the distributive property, there's nothing in the middle, okay? But you have to realize that when you multiply this by this and this by this,
They just cancel out.
they just disappear, exactly, okay? And then we do the last part here. And so this is subtracting, so negative times a positive, subtract, and this is 9 plus x on top.
All right.
And then just, you know, like a bunch of stuff on the bottom.
Yeah.
Might
Can
help
we
to
just
remind me
do 3?
Oh. Sorry, what was that, Maddie?
like what I do to help remind me of like what to do with that is I put the little round brackets around like the top on both sides. So then I kind of like remember to use the distributive property. Remember, I couldn't remember how to do it the first time. And then, yeah, so if you just put like the brackets on the top, it helps.
Oh, like,
You know what I mean?
like right here?
Yeah, but like over the square root of 9 minus x, like on the top of your original function, like keeping that as like 1 unit, and then
Yeah.
multiplying it by another thing that's 1 unit. Like that's what helped me more.
Oh, you're saying like here you put brackets on, or?
Yeah, but like around the whole thing.
Oh, okay. Oh, I see what you mean.
Yeah.
Going like that,
I
and
find it like,
suddenly
easier to identify that then you need to use the distributive property when it looks like that.
Yeah, that's true, actually. That is true. Does that help, Johnny?
Yep.
Okay, yeah.
I did it yesterday, I just forgot.
Yeah, but I can see like all at once this triggers your brain, nightmare from grade 10 or whatever, that you're doing the distributive property. Yeah.
The
Maddie, thank you.
Thank you.
Jeez. We owe like a debt of gratitude for Maddie for like sticking with us. But yeah, no, that's a good idea. Put those brackets around there, and then you know when you look at it, oh, I'm doing the distributive property.
Can we do number 3 and then?
I sure can. Yeah.
And then I'm gonna do the x. So I screw that up.
Oh, I haven't done any of the exit tests yet. I didn't know if we were supposed to do this. I'm going to go back and do them.
They're there. You don't get overly excited about the exit tests. Like, yeah. Because the big important thing is just going to be.
Just a reminder, there will be a Robin Hood rehearsal today at the lunchtime in the music room.
There's a Robin Hood rehearsal. I want to be the fox. I guess that's ambiguous because there were 2 foxes in the original medieval Robin Hood. Okay. All right. Put in a 0. Ah! Bad things happen. Okay. And this is the limit from the right or the limit from above as x approaches 0. So this becomes indeterminate if I just throw in a 0. Okay.
Can you do like, oh, you have to multiply it like that?
Yeah, so we do this thing where we rationalize the denominator. Okay.
Okay.
So I haven't put my limit in yet. Approaching it from above. So in the example that we did yesterday, oh, right, you were away yesterday.
Yeah.
Okay. All right.
Oh.
Okay, these absolute value brackets are here for a reason, and then that reason just disappears when we talk about taking the limit from one direction only, okay? But basically, shh. Your cat does not respond to English. Well, I guess shh isn't English, really. Okay. This operation of squaring a number and then taking the square root always strips off the negative signs, okay? So if we just write it as 3x, we're going to run into trouble when x is negative, okay? This and this, even though based on our understanding of grade 8 math, seem equivalent, but if x is negative, this is going to make it positive. So I can't just write it as 3x. I have to write it as 3 times the absolute value of x. Now that I've explained that part, we're approaching 0 from above, okay? So in other words, I never have to worry about x being negative because I'm approaching it from above. So I don't have to do those cases. I don't have to approach this as cases anymore, okay? I'm just gonna do the one case where x is greater than 0. So there I am. So here's where the magic happens. I can cancel an x here with one of these x's on the top, okay? So now it becomes x times square root of 3x over 3. Oh, look who almost forgot to put the limit sign on there. Okay, there we go. And now I just substitute 0 in, and I get 0. That's that.
There just seems to be, like, with the absolute values, there's like a lot of steps that, like, I have no idea when I'm supposed to apply those.
Okay, what if I told you just go about rationalizing the denominator and see what happens?
Can you just do like x times x over x times the square root of 3?
Oh, like this. No. That basically this turns indeterminate, and I can probably fix that if I can cancel one of the x's in the bottom with the top. Okay. Right now I've got something underneath the square root sign, so I guess I could do that.
Just one sec.
That would work. It would be a little more awkward, but
I don't know if you can like see through on the page.
I can actually just hold it up and it'll be fine. A little closer. X times x. No, because the x is underneath the radical sign here.
But is that not just the same? X times the square root of 3 is the square root of 3x.
Oh, so I don't know if it's clear or not, but this is the square root of 3x.
Oh, okay.
Yeah, so the x is underneath the radical sign.
Yeah, okay.
Yeah, so we got to fix it.
Okay, for this exit test, it says give the equation of the horizontal asymptotes of whatever this is. I don't really know what you're supposed to do.
All right, is the degree of the top equal to the degree of the bottom?
Yeah.
Okay, what's on top?
Negative 4x plus 5.
And what's on bottom?
Negative 2x plus 5.
Okay, so the horizontal asymptote is just basically negative 4 divided by negative 2. Which is 2. Yeah. I'm sure. Eric's saying no.
Plus 1 or?
Well, Johnny has a different one. So this is his. Yeah. As x goes to infinity of negative 4x, negative 2x.
It doesn't say it has any limits. It just, this is the equation.
Yeah, same idea though. Like when we're talking about these limits at infinity, we're often talking about asymptotes. So, okay, so it's negative 4x plus
5.
Plus 5, negative 2x
Plus 5.
plus 5. Okay, the degree of the top and the degree of the bottom are equal. And so all I have to do is look and take negative 4 and divide it by negative 2. And so that heads for 2. So that's my horizontal asymptote.
What about like the plus 5 and plus 5? That makes 1, does it not?
Yep, it would just be 1.
So plus 1?
Just 1. Don't put a plus or you'll get in trouble.
Oh, they just cancel out?
Yep, top and bottom cancel if the degrees are the same.
But do you keep that plus sign, or does that plus sign just go away?
Oh, like if you're entering your answer, don't put a plus sign on or it'll be bad. The computer's dumb.
No, but I'm saying, like, yeah, negative 4x divided by negative 2x is 2.
Yep.
And then 5 divided by 5 is 1. Do you add that 1, or?
Oh, you definitely don't. Okay, because x is getting really, really huge. This is a great big number times 4, times negative 4. And this is a great big number times negative 2. And the 5 pretty much doesn't change it. Changes a little bit. So
In advanced functions, we talked about like just like an easier way of looking at it even is anything that doesn't have the variable in it is sort of like negligible.
yeah.
Which is sort of like the same thing that you're saying.
Yeah. 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 And when we went through that exercise where we were dividing. All right. Good.
Well,
Maddie, thanks a lot.
Thank you. All right. Is there going to be a video conference tomorrow? Or is it just going to be like working on review problems?
Yeah, so there's no formal video conference, but I'll leave open a video room. I think if I get my act together, I wanted to do a little knowledge hook like game show thing. That
Like a Kahoot?
Yeah, they're like a Kahoot, but of course they're way cooler. And yeah, but if I get my act together, we'll do something like that. That's going to go over the 5 kinds of questions we're going to do.
Perfect. All right, sounds good.
Okay, thanks a lot, Maddie.
All right, thank you. Have a good one.
You too.
Thanks.
So this question might like clear up what I was asking. So the top's 5x plus 5, and the bottom's 5x minus 3.
Yep.
So 5x divided by 5x is 1.
Yeah, and these just basically, as x gets big, these are negligible.
Oh, so I shouldn't even be looking at those. So that doesn't.
Yeah, you shouldn't even be don't even waste your time.
All right.
Yeah.
Why?
Yep. So it's 1. And if you really want to cheat, you can just put them in Desmos. That's how Eric got through grade 11 and grade 12. Just put everything in Desmos. The answer is, get to university though, like they don't let you use Desmos on
The
All right.
Okay.
Okay. So this will be open. I'll try and leave it open. Maybe not period 4. Well, I can put it up period 4, but there might be some confusion and stuff in here.
Would you be able to reopen that one exit test that I got 33 on?
I don't know. Maybe you deserve 33.
Definitely was a glitch.
Yeah, I can open it up. Yeah. Send
Forget
me an email.
Forget which one it was.
You can actually look in the grades and you'll see like this really devastating 33%.
I think it's limit methods. Yeah, it's limit methods.
Okay. All right. If I don't get it done, just send me an email.
All right.
Okay. And if you've got any more questions, like just pop in.
All right. Sounds good.
Okay. Good. And Morgan, I can't see you, but if you've got some questions, I don't know. Like this will be open, and I can leave it open again. I can leave it open again like a little while after school as well if you've got questions then.
Is there a review that you can give my dad, or do you still have to make it?
No, I'd just make it up and I'd email it.
Okay.
Yeah.
And when do you think that will be out?
I don't know. Maybe tonight.
Okay.
Yeah.
Sounds good.
Okay.
All right. See ya.
Yeah, we'll see you, Johnny.
Bye.
Question on piecewise function.
Yeah.
How do I go about
Okay, so
If the substitute maybe.
Yeah.
I just got lost. Like I did that, but
oh, okay. Just show me what you did.
I threw the finger.
Okay, you got angry and threw it out. Okay, I'm just gonna go grab some lunch. I'll be back in a flash.
Okay.
I guess I could stop the broadcast, eh? There's only a certain amount of data we want to give up to Google.